So let's talk about Python, because when you say Python, you probably think, for the first time, you probably think of some, big green, massive, kick-ass snake that's going to bite off your head, something, like this. The snake is, fast and deadly, and it's very much like C++. But as you start, digging into the Python, you find out that it's not so. It's more like this. It's Python is adorable, like really lovable, and very much like this sleuth. It's like, but it's very slow. You find out that very fast. And by this time, you got very used to the, like this very high-level programming, and you're used to that. You like it very much, and you don't want to go back to the snake, because it's trying to bite your head off, and it has big teeth. And what you actually are looking for is something like this. It would be nice to have a C++ snaky backend and this adorable front end that Python provides. I think it's a very good picture. I made it myself. So that's when the Pybind11 comes in place. Pybind is a C++ library that provides Python bindings of C++ code. It's very easy to use. It exposes all the fancy types, and you can define in C++. It's very lightweight, header-only, easy to use. And what's most important is that it exploits the modern features of C++11 and later standards, unlike the older version of Boost, which Boost bindings to Python and this kind of stuff. So let's see some examples, because that's what we want, right? So here is an example of some C++ code. It creates. We define point. We defined a function that uses Mr. Graham's convex hull and convex hull algorithm and tries to compute it. And then we define this, magic syntax down there that says that we are about to define a Python module. It's called unicorn land, because we want unicorns. And then we define a point. We define its constructors. You can see that it's very easy to define constructors. You just name the signature of the point, and it just does its magic. And then you say it has some attributes like x and y. And then you bind the convex hull algorithm. And then you go to Python, compile this thing, and import it to Python, like this. It's very simple. And so here you can see I created a little HTTP server that just has this convex hull endpoint, and it accepts points in JSON, parses it, sends it to C++, and computes it and sends it back. It's very easy. And so that's what you can do with Pybind. And another thing is that in Python you usually get into problems with with GIL, the global interpret log, because Python relies heavily on that. And you can help this. You can make actually Python truly parallel by using executors, because you don't want your asynchronous function to block. And then in C++, when you define your function, you can release the GIL if you are sure that your resources are safe. You release the GIL and you obtain the true parallelism. Like, that's the holy grail probably in Python, because it's Python. There are loads and loads more features that Pybind currently supports. The maintainers are working very hard to add more and more stuff, and it's great. And that's about it. You can find it on GitHub. There is a link. And thank you very much. If you have questions, just find me later.